Hello students, welcome back to the another session of our data structure journey. Right now we are covering the searching and sorting algorithms. We are already covered searching algorithm, that the linear search, binary search. Right now we are covering the series of sorting algorithms. And today we are going to learn what is a selection sort and what are its operation, how it performs operations. So in this video we are going to cover what is a selection sort, how the algorithms work, and we are going to implement it in the C language. Then we will cover the what is the time and space complexity. Then we will cover what is the advantage, disadvantage of the algorithm. Then what are the application in the real world. So let's start the selection sort. So here what happened, the entire list is divided into two parts like the insertion sort. First one is the sorted list, another one is the unsorted list. At each and every iteration, the minimum value from the unsorted list is calculated and swapped with the first position of the unsorted list. Means we are stored the minimum value from the unsorted list to into proper position, that is the first position, and the process will continue until the entire list is sorted or end of the list. If you traverse means end of the list, automatically the array is sorted. So next question, how many number of iteration it will perform? It will perform the iteration, that is the number of element present inside the list. So let us understand how it's perform its operation. So before the iteration, the values are 25, 10, 45, 20, and 5. So this is the index, that is 0, 1, 2, 3, 4 if we are store the value in the array. So now, as I have already told you that the entire list divided into two parts. First one is the unsorted, second one is the sorted. So this is, for example, sorted, this is unsorted. So now we have to find out the minimum value. So which one? That is the 5 is the minimum value. So 5 value we have to make the swapping with this element. Means 20. First position. First position of unsorted array is the 25. So we have to swap this element, that is 25 to 5. So here what happened? I have to store the 5 value. Here I have to store the 25. Then remaining elements are same. So after first iteration, what happened? The first minimum value stored inside the first proper position. So here now, this is our sorted list after first iteration. This is our unsorted. So this is after first iteration. Next, the next iteration, what happened? We have to search the minimum value from the unsorted. So now unsorted list this one. So from this value, we have to find out the minimum value. So which one is the minimum value? So minimum value we have swap with which element? First element. So it is itself. So here what happened? The same thing here. No changes will be happen. So 25. Now this is sorted list. This is unsorted list. So unsorted list, this is it. So after the second iteration, what happened? Two elements are in sorted position. Now go to the third iteration. So third iteration, what happened? Minimum value from the unsorted list we have to calculate. So which one? Now 20 is the minimum value. So 20 is the minimum value. So we have to swap with which element? First location of the unsorted. So this value will be swapped right now. So now here it will be 20. This is 25. Remaining elements are same. So now after third iteration, this is sorted list. This is unsorted list. So now what happened? Three elements are sorted after three iteration. Now fourth iteration. So we have to find out the minimum value is 25. So 25 we have to swap with the which value? 45. Then what happened? fourth iteration, the value is comes to the first line. Then here what happened? Here the 20, this is 10, this is 5. Now you just say all the elements are sorted or not. So now you tell me how many number of iteration we require. We require the number of iteration is the n minus 1. So next we have to know what is the algorithm for the selection sort. So initially we select the small element from the list, swap it with the first element, hence the smallest elements put into the proper position. Next iteration, we select the smallest among the remaining element. That is the smallest, second smallest. The same procedure we have to follow till we reach the end of the list. So this is the way we have to perform its up. Next, we will go to the implementation of the algorithm in C language. So this is our program to implement. So we have to include the header file. Next, main function. Inside the main function, for example, I declare a array where we store the elements list, all the elements present inside the list by help of the one dimension list, one dimension array, that is the A with 5 elements. It can store the 5 elements. Then size of array we store with the J variable. We require two variable for inner loop as well as the outer loop for execution. So for that I require two variables. So I just make I and j. And whenever we go for swapping, we also require third variable for the swapping. That's why I use the temp is the variable. And whenever we are searching for minimum value of a unsorted list, we also require that index so that we can able to swap the element with the first position of the unsorted list. So here I make the variable as minimum index. So these are the variables we require. So let's start the program. So printf new line. So it will ask the please enter the number of list. Means it will ask the end user to enter the size of array, means how many number of elements it will store. Then we have to scanf. So scanf %d %n. So n is the variable is going to store the size of array. So then we have to ask the user to enter the value into the array. So printf new line, please enter the data into array. So it also read after tab, it will read the value. So, or we can go for the new line. After that, it will create a new line. So here, please enter the data into this list. So what we have to write down? For I equal to 0, I less than equal to n minus 1, because indexing starting from 0 to n minus 1, then I plus plus, then we have to scan it. Or we can make the for each and every iteration, it will ask the enter the data. This is the way we also can do it. Means it will ask each and every iteration enter the value. So here what happened? We have to make a starting curly bracket, then this data will be for then scanf %d percent a of I. So it will read all the value present inside the array. So it will read one by one. Then we have to end the for loop. Means it will read the value. So this is the way for the reading data into array. Once we read the value, then what happened? We it is our choice whether we want to print the data before the sorting, after the sorting, it is our choice. So in this program, I just want to print the value before the sorting, printf. So it will create two lines. Then before the selection sort, the array elements are new line. After new line, the elements or the same line after tab also it can print. Then here what happened? We have to use the for loop for I equal to 0, I less than equal to n minus 1, I plus plus. Then we have to print the value. Printf %d. We want each element should be separated by one tab. That's why I make the %d tab. Then so it will print the before the sorting. So now selection sort. We have to start the selection sort. So here what happened? As we know that we have to perform the number of iteration, that is for I equal to 0, I less than n minus 1. So here we have to go to up to n minus 1. Then I plus plus. So this is for number of iteration. And each and every iteration, what we have to do? We have to find out the minimum value present inside the unsorted list. So for that, we have to start the indexing from which location? Now, here what we have to do? We have to check whether minimum index value is, means next value is the less than the minimum value. So what we have to check? If aj equal to is less than equal to aj mean index, means we got a value which is less than the mean index value. Then what happened? We have to make the mean index equal to j. So once the for loop is over, then we have to perform the swapping because we are already got the minimum index of the minimum value. We are already got the index of the minimum value. Once we got the index of minimum value, then we have to check whether it is first element or not. If it is first element, no need for swapping. So for that, we have to go for if ai is not equal to a mean index, then we have to do the swapping. So here what happened? We have to make the temp equal to AI. Then AI is equal to a mean index equal to temp. So swapping is done with the third variable. temp. Then once the swapping is done, so what happened? After each and every iteration, we are put the minimum value in the proper location. So once the for loop is over, means all the data is sorted. So we want the print the value after the sorting. So the same statement we have to write down here. So I just copy paste here. So instead of before, I have to just write down after. So after sorting the elements of this. So now we have to write down let's see yes. As I make the main function as a integer return value, so I make the return 0. So main function is over. Let's compile the program and check whether we have any error or not. No error. Good. So please enter the number of list. So I enter 5, first element 10, then 34, then 60. So this is sorting or not? Yes. Before sort, we enter the elements are 10, 34, 76, 56, 99. After sorting, the elements are 10, 34, 56, 76, 99. Let us execute the program once again. Let I enter the value is 10 means number of elements we are enter the 10. So we enter all the element in the reverse order. 5, 0, then 4, 0, then 33, then 22, then 1. So it is showing the, yes, we are got the correct answer. So this is the implementation of the selection sort algorithm. Next, we are going to understand how the program is actually executed. Our complete program. In this program, this is the main function. Inside the main function, we read the value. Before the sorting, we print the value. This thing I have already explained how to read the value, how to print the value, all the things in our previous video. That is the operation in the array. So you can go to refer this one. I will definitely put the link in the description section. Only we have to understand the selection sort algorithm. So whenever the selection sort algorithm is going to implement, this is the part of the main function. This is the main thing we have to understand only how the operation is performed. I think maximum students already understand this one, but let me explain once again. So here what happened for I equal to 0. So what we will store the value of I equal to 0. Then mean index. Mean index is the index of the minimum value. So for example, we assume the first value as a index, minimum value. That's why we make this one as a mean index. Then, so this is the loop is used to find out the minimum value of a sorted unsorted list. From there, we are going to calculate index. So now here for j equal to I plus 1 means 0 plus 1, this is 1. Now aj. What is aj? Aj is 10. 10 is less than a minimum index. What is the minimum index? 0. 25. If it is true, then what happened? We have to make the mean index equal to j. What is the j? 1. Now mean index is changed to j. Then it will go to ending curly bracket. They go to starting curly bracket. Then what happened? J value is incremented by 1. That is 2. So now, what is the aj value? Aj is A2, 45. 45 is less than A1. What is A1? 10. No, this is not true. If it is not true, then what happened? The next line will not execute and J value is incremented by 1, that is 3. So now A3. What is A3? 20. 20 is less than A mean index. Mean index is now 1, that is 10. If it is true, no, it is not true. So what happened? Again, it will go to the increment the j value, that is the 4. Now A4, AJ means A4. What is A4? A4 is 5. So now 5 is less than a mean index. This is 10. So whether it is true? Yes, it is true. If it is true, then what happened? Mean index equal to j. What is the mean index right now? 4. So now it will converted into 1 to 4. Then j value is incremented by 5. So next one we have to. So with the first for loop, what happened? We are already got the index of minimum value. So this is for first iteration. This is our unsorted list. From unsorted list, we are got the index, that is the 4 is the index of minimum value 5. Now we have to check if ai, that is I value is 0, whether 25 is not equal to a mean index, that is 5. If it is true, then we have to show. For example, we search and we will got the same value. So no need to for swapping. That's why we are write down this code. So if it is true, means mean index value is not the first element, then what happened? We have to swap. So what happened? We store the temp equal to ai. What is the ai value? 25. Then ai store the mean index. What is the mean index? 4. That is the 5. So it store right now which value? 5 value. Then a mean index store which value? 10 value. That is 25. So after first iteration, what happened? We got the value. This is 5, this is 10, this is 45, this is 20, this is 25. So what happened? So this is sorted data. Now, so it will go to ending curly bracket, go to the starting curly bracket. Then it is 1, means second iteration. I value is 1. So what happened? Whenever I value is 1, mean index which value? I value, that the first one. Right now we have to make this one is the minimum index. Then j equal to I plus 1. J means right now I plus 1, because this is the first value, then we have to start from this value 45 onwards. So we have to go for compare this element with the remaining element. That's why for j equal to I plus 1, I less than. So same procedure we will execute at the end of the iteration. We will got the sorted array. So let's understand the time complexity of the selection sort. The time complexity generally measured in terms of number of comparison. So for first iteration, we have to compare the n minus 1 to find out the minimum value. So for second iteration, we have to compare n minus 1, n minus 2 comparison to find out the second minimum value. It will for third iteration, n minus 3 to find out third smallest value. So on we have to compare. So total number of comparison we have to perform, that is n minus 1 plus n minus 2 plus n minus 3 up to 1. So total number of comparison, that is the order of n square. So from that is the order of n square when the array is already sorted, where the number of integers are n, means if n number of elements is present for the sorting the array in case of selection sort, time complexity is order of n square. For average also is the order of n square whenever it is randomly, because anyhow we have to traverse entire list, as well as for each and every number we have to calculate for the minimum value. So for the random order or without any disorder or any position fix, in case of average also, this is the time complexity is order of n square. For worst case, whenever the data is stored in the reverse order, means reverse sorting order, then also we require the time complexity is order of n square. Next one is the space complexity. So here what happened is required all time space complexity, that is the order of 1. Reason is that it only required the temporary variable for swapping the elements. Because whenever we got the minimum value, we have to swap with the first index of first element of the unsorted list. So at that time we require swapping. Here we are using the third variable. For that we require a constant time period. That's why the space complexity is order of 1. What are the advantage of this algorithm? So it is very easy to understand and implement, making it deal with the teaching basic concept of sorting. Means whenever go for the what is the algorithm, how the sorting is going to be performed. So it is very easy to explain students as well as to implement. So it's required only constant time. It does not require more constant time that the order of n square, as well as it requires the extra memory space. Only that is the order of 1. It requires smaller number of swap, because in case of insertion sort, so many swapping is required. But here what happened? Only one swapping is required for each and every iteration. That's why it is very very much less swapping requirements compared to the bubble sort. But in case of bubble sort, what happened? For each and every iteration, each and every element we have to compare and we have to swap it. But there are so many disadvantages, because the order of time complexity, that the order of n square, if we compare with the quick sort as well as the merge sort, so it is very slow. It does not maintain relative order of equal number of elements, which means it is not a stable at all. So what are the application of the selection sort? So it is initially the what happened, we can use for the more complex algorithm. This algorithm can be used for the preliminary step or more complex sorting algorithms or hybrid algorithm for the small set of data. It is very suitable for the small set of data, that if the number of element present inside the list is very less, then it is very easy to implement. This algorithm we can also use for educational purpose, because whenever you go for the teaching to students to how to perform the sorting, it is very easy. Memory constant environment, because because it's required the memory consumption or space consumption, that is the order of 1. So whenever we have memory constant, at that time we can, or less number of memory is available, at that time we can go for this algorithm. The algorithm is, when we are dealing with the array, small number of unique elements is present, then it can also work very well. So this is the all about our selection sort. We are already implementing the C language. Hope you are able to understand. Thanks for watching the video. Please subscribe the channel, like the channel, share the channel. Thank you so much.